Hi students, Assalamu alaikum. How are you? Hope you are studying your lessons every day. And right now we are going to study our next lesson. It's about electron affinity.
Well, students, so what's electron affinity? Electron affinity is defined as the energy process in which an electron is acquired by the atom in the gas phase. We have studied electronegativity and ionization energy. What are the differences between them? Electronegativity was a chemical property of an element that decides the tendency of atom to attract atoms in a covalent bond. Like how much does it attract an atom from outside? Is a kind of qualitative property, okay? But electron affinity is the quantitative property. And if you remember from ionization energy, I told you that in ionization energy, if you want to remove an electron from a neutral atom, we want to turn it into a ion, a positive ion. So the energy that was required is known as ionization energy. But for electron affinity, it's totally different. Let's see that if we have a lithium atom, it's a neutral lithium atom, okay? And we want to give it an electron. We want to give this electron to the neutral lithium atom. Now it will turn to lithium ion or anion. And at the meantime, it will release some energy. The energy which is released is known as the electron affinity energy of the lithium. And it is and its unit is kilojoule per mole. For lithium, we have minus 60 kilojoule per mole energy. It's electron affinity energy. Okay, let's see what is the trend across a period for electron affinity. For electron affinity, if we go from left to right, it increases across a period. Let's work upon example for the period 3. We have seen that we have studied that for lithium it was minus 60 kilojoule per mole. Minus designates that is the exothermic reaction which is giving energy. Okay, for beryllium it's 0, for boron minus 27, for carbon 122, nitrogen 0, oxygen 141, and fluorine 328. Fluorine has the highest electron affinity energy. Neon is the 0. Okay, why beryllium is 0 over here? What's the reason? We have to look up on its electronic configuration. The electronic configuration for the beryllium is 1s2 and 2s2 and 2p0. This is the electronic configuration for the beryllium. But when we add up an electron, what happens if we add up an electron into this part like this? In this case, this 2s2 orbital repels this electron. This property is known as shielding effect. So because of the shielding effect, it cannot accept electron. So the electron affinity for beryllium is 0. And if we want to give it electron, then we need to push up, then we need some energy. So normally it won't accept 0. For beryllium it's minus 27. Now we can see a trend. It's increasing. For nitrogen it's 0. Why it's 0? Let me show you. For nitrogen, if we want to write the electronic configuration of nitrogen, 1s2, 2s2, 2p3. Okay, so let me show the orbitals. This is for 1s2, this is 2s2, and these are the 2p3 orbitals. We have 2 electrons in the 1s2 orbital. 1, 2. 2 electrons, 2s2, 1 and 2. And we know that according to the electronic configuration, those rules that we have studied in previous lesson, each of them will have 1 electron. And now, if we want to add up an electron in this part, like this one, this electron will push this one. And it won't accept this electron. So there is some kind of shielding of this electron. They want to live in the same orbital. That's why the electron affinity for nitrogen is also 0. And I told you that the highest electron affinity value is of fluorine. Okay, now let's see what happens with the column. The trend across the column for electron affinity. As it goes down, the electron affinity decreases. What's the reason? We know that with every period, one shell will be increased or one shell will be added up. Hydrogen, one energy level, 2, 3, 4, 5, 6, and 7. Francium will have 7 energy level. So the attraction of the attraction of nucleus to the outer electron will get less. The atomic radius will get higher. So as much as the atomic radius will get higher, the electron affinity will be decreased. So this is a trend across a column for electron affinity. Let me tell you again, as much as the atomic radius increases, the electron affinity will decrease across a column. Okay, students, so we are finished with today's lesson, and if you have any question about electron affinity, you can write in the comment section below. Thanks for watching our video. I hope you will subscribe our channel and give a thumbs up. Goodbye.